All right, so now we're going to look at some slightly more complicated shapes. This time we're looking at what happens when we have four edges where opposite edges are going to get associated. And just like in the last example, edges that have the same letter are going to get glued together as our vertices. And in both of these examples, all of our vertices are going to end up in the same place. So I'm just going to label all of those vertices P. And to give you a little bit of an idea of why that's going to work, well, in this first example, actually in both examples, both edges A are going to get glued together with the same orientation. So that will take the top left and bottom left points to the same point, and the top right and bottom right points to the same point. Again, just like the last one, we're going to have one slight difference between these two examples, and that's going to be the orientation of the second pair of edges. So in this top example, I'm going to orient my B edges like this, and in the bottom example, I'm going to orient my B edges like this. Okay, so in the first example, well, actually both, I'm going to start by gluing my A edges together. And when we have a square and we glue one pair of edges together, what's going to happen is that we're going to end up with a cylinder. And so here's my cylinder. And so I've got, let's see, we'll say those B edges are kind of oriented like this now. And I'm going to highlight where edge A has gone in blue here for you. Okay. And so the same thing is going to happen down here. We're going to end up with a cylinder. But down here, my B edges are going to have opposite orientations. So I'm going to put this one this way and this one this way. So there's the B edges. Okay, so now in gluing together those B edges, what we're going to do in this first case is I'm going to bend this cylinder. I'm going to bend that cylinder around, kind of like so. So there's my cylinder. And because of the way those B edges are oriented here, I can glue them together pretty easily without having to do anything weird. And so what we end up with in this case, so here's that place where we just glued. So what we end up with here is called the torus, and this is an orientable surface of genus 1. So it's a sphere with a single handle. All right, so then now what happens down here? Well, before I try to glue these B edges together, I want to show you what would have happened if we had glued the B edges together first. So because they have opposite orientation, I have to put a little bit of a twist into them, what we call a half twist. And so if I just glue together the B edges, that's how we get our Mobius band. So here's my little Mobius band. Mobius band or Mobius strip, or whatever you want to call it. So there's your B in that case. Okay, just wanted to show you that. That's not what we're specifically looking at right now. All right, so let's return to our cylinder. So when I bend these guys around this time, I want you to notice that the orientations, rather than being mirror images of each other, which is what we have here and here, right? So those match together really well. What we end up having now is that the orientations go the same direction. So I can't just glue them together directly. So what we're going to have to do is allow this thing to pass through itself in order to line up those edges. So I'm going to highlight those B edges so that you can see where they're going to end up. And let's see if I can draw this thing. Usually I can draw it fairly well. So hopefully you saw where this was going. And so what happens here is that we get this thing called a Klein bottle. And so that's actually inside of this thing. So our Klein bottle, just like the projective plane and the Mobius band, an example of a non-orientable surface.